Okay. I'm recording the voice separately from the video, so maybe it will interfere somehow. Well, I don't know. Okay, doesn't matter. First, I'll show you the map. This is a typical map of optics. So our software, as you can see, this is Microsoft Visio. So all our software is an add-on to Microsoft Visio. Well, you can easily access all the code by pressing Alt and F11. So you get to the Visual Studio. So you can code via VBA here, see all the codes and the add-ons and wait a second. Better. Yes, so you can see all the codes of all the programming. So when we start constructing an optical network, we start with a map. Here you can see I push Ctrl W so we can see the whole map. Here it is about 600 optical nodes, and this is a part of Moscow, one of the Moscow districts. So, well, first we get some Google Maps data and convert it to Visio so we can have a beautiful map. Then we make all the objects get to separate layers. So in the layers menu you can see that all our structure is on the separate layers. And then we create the buildings, the optical nodes, the cables, and whatever. And inside this map, we've got all the mathematics. So here you can see the, how's it called, special properties or something like that. So you can see the special properties of any building. It has its address and other stuff and whatever. So an optical node which is being put let me see, isn't it blocked? No, everything is unlocked. So an optical node, when it is being put on a building, it inherits its address and all other stuff. So the cables, you can see the length. The length is a projection on the map, and it depends on the scale of the how's it called? On the scale of the page you are drawing on, and you can see the number of fibers and number of fibers used and the first node it comes from and the second node it comes to. So, and here you can have a call out showing its length and the number of a cable, or you can easily adjust this number so it can show, for instance, the type of a cable, or for instance the number of fibers in the certain cable. So, well, you can change the cable, for instance, this cable from 4 to 12 fibers, and then, well, we click on the call out and press F5. Something strange happens. Well, that doesn't matter. Anyway, this is how we construct the map. So inside all these cables, lots of signals are being sent, and they are easily calculated, and so you can, well, meter the optical power. And first of all, the most important thing, you can make the optical crossing. So the crossing of the fibers. Well, I'll now show you how does it look like. We'll get to somewhere like from 2. Well, give me just 1 second. Here we can see let's see some optical crossing which is being generated from the map. So this is how the crossing look like. So you can see all the cables, all the crossing, and the optical splitters and whatever. So it is easily managed from the map. Yes, this is the fiber crossing. So back to our map. Tonight I'll show you three main functions. The typical power meter for plain optics, power meter for passive optic networks, and the third thing, how the structure is being made and carried out, and how the calculations are being carried out. So I'll now close the Visio and open some template. A Visio template, you can use one. And here you can see the optical structure with optical splitters and the power meter. So we have the optical source. It's a transmitter. You can adjust its power in decibels very easily. We have fibers. You can adjust its length easily. And we have splitters and whatever. So we have a branch of optics. So every dashed square is an optical node in a separate house. So in every separate house, part of the optical signal is being divided and used for digital television over fiber. So on each house we put a splitter, and the nominals, so the values of a splitter, they are being calculated automatically. So, for instance, if somehow if we somehow adjust this length to, for instance, 10 kilometers, we can recalculate the scheme, and what will it look like? Yes, it is being recalculated. The calculation is meant to find the most small delta between the power nodes, so that the power values, the values of optical power, should be as close to each other as possible. So, for instance, if we want to create some structure, I'll show you how it works. Well, this is a derivative from the major functions. So we take an optical source, we get some, for instance, we get some houses, for instance. What else? We can put splitters here. We can copy them, or we can create our own ones. So here we type the number of outputs, for instance, like this. So the numbers 5 and 95, they are just typical. It's okay. We can put it here inside the houses. And okay, now we connect them with fiber. Damn it. Okay, this should be 100 meters. This should be also 100 meters. This should be what? This should be, okay, let it be, no matter how long it is, let it be 300 meters. Then, we have another building. Okay, let's create another splitter. Put it in the house. Now, this house will be the last one. We take some endpoints. Here we have some endpoints. Okay, let's, well, we will have two endpoints here, okay? Now, let's say this is just 5 meters for inside the box. Okay. Very sticky. Okay, here we come. Oh, I apologize for that. Okay, now it's fine. Now we have to connect these endpoints with the splitter. Okay. And sorry. And the last one. I hope it will work. Ah, we have another house. Let's say we have to connect this particular house from this one. So we have to make two splitters here. Okay, I'll add one splitter. I'll put it here. I'll reconnect the optical source. I'll take a new fiber. Say it's just 1 meter. That doesn't matter. Okay. Let's connect this one. So this is just it's a variety of an optical structure. It doesn't matter. So in order to get the optical power inside the houses, we have to calculate the nominals of the optical splitters. So we click on our optical source and click on calculate. Look at the splitters. So now they are being calculated. But next we should send the signal. We send the signal and we get the results. So the numbers on the endpoints have changed. So what do we get? The results, we get 5 endpoints. The minimum power is 0.15 decibels. The maximum power is as follows, and the delta between them is as follows. And these are just the parameters. So on a fiber coupling, not coupling, but on a fiber fusion, we have a loss of as follows. On an endpoint, we have such a loss, and this is the kilometric loss. So we can see that the numbers on the endpoints, they are nearly very close to each other. So, well, this way you can create a scheme of, well, any size you like. You can add hundreds and even thousands of nodes easily. Also, you can adjust the power transmitter and recalculate the scheme, and you can see that the power on the endpoints has changed. What else we can make? For instance, if we create a splitter, for instance, with 2 outputs, we can manually set the output parameters, the parameters of the outputs, for instance, 30 and 70. And if we put it, for instance, instead of this splitter, we can recalculate the scheme. Well, look at the endpoints. We can recalculate it, and well, we get the numbers when such a splitter is used. For instance, if you need such a splitter, if you want this splitter also to be recalculated, you just click on the transmitter and push calculate, and look at this splitter. The numbers has changed, so it's being recalculated. After it's being recalculated, you can't adjust it. It will stay as it is calculated. So this is how it's being made. This is just something typical. Well, of course, after you draw it, you make it look better, and well, I mean that it should be made to look better. Well, like here in this example, in this particular example. So, well, to work with it, you just take a sample file. You can easily, well, delete what you don't need and move on and create your schemes and calculate everything you need. Well, there's another interesting function. For instance, you have a power transmitter and you have, for instance, 2 houses somewhere. So let's put some endpoints here. And let's create a splitter. And for instance, you have a task not to calculate how much power we'll get to the endpoints, but there's a certain task. For instance, when you know the distances, for instance, you have different distances, and this endpoint represents some part of a network or a group of houses or whatever. And for instance, you really know the demand for power. For instance, here, the second line is the demand. For instance, here you demand 10 decibels, and here you demand, for instance, well, let it be 13 decibels. And your task is to calculate the splitter to meet these needs, also including the lengths. For instance, you know the length and you know the demand. This is how you can calculate the splitter. Let it be, well, 1000 meters. So here we click on the power transmitter, and we press calculate the splitter. So now we get the parameters of the outputs of a splitter, which gives us now we calculate it. Okay, so for instance, if we demand 10 decibels here and 13 decibels here, we get such a splitter, and doesn't matter which power you send to the scheme. So in this way the scheme just calculates the demand. So it's a reverse task. Very interesting, isn't it? Okay, let's move on. Let's close this one, even won't save it, and then let's go to a template for passive optical networks. It look nearly the same, but just you have the same power source, and you can adjust the power here in decibels also, and this is just something unneeded. That doesn't matter. Here we have a multiplexer, and here we have transmitter for cable television, and you also can adjust the output power in decibels. Here we multiplex it. We also have the splitters, which can be calculated easily, and for in the houses we have PLC splitters with some number of optical network units, or optical network terminals, you can call it as you like. For instance, you can see if we say that we have, for instance, 16 units here. Sorry, basic outs 16. We can now look here. We push recalculator scheme, and we get the new numbers. But the numbers are incorrect because we just calculated the power. We didn't recalculate the splitters. Now we once again click on the pawn transmitter pawn terminal and push recalculate. So now all the splitters are being recalculated, and we can recalculate the power. Once again, we push recalculate the power, and now we get the power with the minimum possible delta. So the delta is as follows. So this is very easy. Also, well, if you want to create your own scheme, it's very easy. You take your power source, you take the CAT source, you take some splitter, which you can then recalculate. We don't need such a splitter. We get the multiplexer. We get some fiber. We connect everything. Okay, and for instance, we have some two houses, for instance. Two houses. One splitter in the first one. Now we once again adjust the length of the fiber. Let it be 100, but it doesn't really matter. Let's connect this one. Let it be no matter what. Connect this one. Connect. Damn it. Connect this one. So now, if we say that we have 16 anodes here, and for instance, 16 anodes here, we think we must get 50 by 50 here. So let's recalculate it. Okay, recalculate it, send the signal, and now we get the new numbers. Okay, we got the new numbers. Now send the signal from the television. Okay, we got the new numbers. It's being read because it thinks that the television power, the TV signal, it's too high. So if we say, for instance, 10 decibels and recalculate, so now the numbers are much better. Okay, let it be, for instance, 15, but it doesn't matter. No, it doesn't like it. Okay, let it be 10. Also, for instance, if in the house, there's only, for instance, 13 subscribers for a passive optical network, you can put 13 here and put 3 as the bonus. So, for instance, if everywhere you put 16 where you need 13, in the end, when you will be calculating a BOC, I think you'll try to calculate the number of outlets and patch cords and whatever concerning to the number of the outputs of all the PLC splitters. But if you have only 13 subscribers here, this is being put here, and in the box you will see that you don't need the 16 of everything. You need only 13 of all the other stuff, and the 3 is just an extra number to make this PLC splitter look like as a division by 16. Well, I hope you get me. So let's recalculate it. This is how it works. For instance, if we say we have 32 subscribers here, we must get one part of power and 2 parts of power here. So it must be about 30 divided by 70 or 35 by 60. So let's recalculate it. Recalculate the split. Okay, and recalculate the signal. Okay, so this is how it works, and you can create schemes of any size you want. That's very easy, as you can see. I won't save the changes. Well, let's move on. And the next very interesting. So the first 2 things, they were the derivatives from the main task, which is being usually solved. It's the construction of a network. So I'll take some template of the network structure. So here we get all our stuff, and let's solve a typical problem. For instance, let's draw some houses and some network structure, just for example. For instance, this will be a house. Let it be a house. Well, let's draw some houses like this one. Then we select them. Then we push this button, and they turn into houses. No, they don't turn into houses because the layer with houses is locked. Now everything is unlocked. Okay, so let these buildings be houses. Okay, so now it has lots of custom properties, and here we can put the address. For instance, address 1. Let it be address 2. Let me copy it. Address 3. Address 4. Please be patient. It's very important. Address 6. Let it be address 7 and address 8 in the end. So now we can select it once again and press what? This button is used for showing the name of the house just near to the corresponding house. Push it. How strange. Something went wrong. Okay, let's okay, let's do it once again. Let it be house. Press it's a house. Then I put its address. And why doesn't it write it? I just pushed the button I didn't need to push. Okay, now we select all our houses. Now I must delete everything unneeded. Now we push this button. What the heck? How is it possible? Isn't it an address? But why is it so? Well, okay. No matter. I haven't used it for several months, so I can forget some functions and something, and well, I will. How's it called? Address 6. Address 7 finally. Address 8. Then we lock everything but network units and houses. Now we select only houses, not the numbers. Now we push create optical units on the houses. Okay, we have created it. So as you can see, this is a building with address as follows. And when we put a node, it inherits the address. So it's the address and this is the name. So this is called the optical cross with the corresponding address. Now we can create optical cables. I just put a line and press create a cable. Now this line is a cable. It is being locked. We can unlock it. We can unlock everything. Unlock everything. So now it is a cable. Its length is being calculated to the corresponding scale. So it's a length of the projection on the corresponding scale of the sheet you are drawing on. So this is the length in meters. This is the number of fibers. You can change it easily. For instance, let it be 16 fibers. And this is the first point and the end point of the cable. Okay, let's create some network structure. Okay, let it be a cable. Let it be, say, 16 fibers. Let it be a cable with, say, 12 fibers. Let's connect these houses. No, not like this. Let's connect it like this. Let it be, for instance, 8 fibers. Let's connect it with this one. Let it be also 8 fibers. Well, that's just an example. And let's say it's a 4-fiber cable, and this is also a 4-fiber cable. What else you can do? You can, for instance, put a call out on the particular cable, so it shows us the number of fibers and the length of it. If you want to put callouts on all the fibers at once, you lock everything but the cables. So now we can select all of the cables and push callouts. So now we have, well, you can a little bit manually adjust it to look better, but now we can see all the types of the cables. What's next? Now we will create the all of the network crossing. We'll create all of the crossing of all of the optical fibers. We'll do it like this. We will first of all we'll make it look a little bit better. We will lock everything and unlock network units. We'll select them and get them to the front. After that, we will select with control pushed. We will select one, then the second one, then third one, then the fourth one. Then we move it to the network crossing. Then what do? We get the crossing template. Okay, and here we press import that 4 units, and one by one they will be imported. So this is the template for the first unit. As you can remember, we have only one cable connected to that unit, so we put it to the right side. The next one has 2 cables. Okay. The third one, cancel. I've made it incorrect. Let's do it once again. We will get it a little bit higher to have more free space, like this. Move this cable to the right. Next unit, it has 2 cables. Next unit has 2 cables with containing 8 fibers each. We'll let them be on the right side. And the next one is as follows. It has just 2 cables with 4 fibers each, and let them stay on the right side. You will see this. This is our structure. So this is the first node, the second node, the third node, the fourth node. Also, you can. These are the cables connected to the crossing to the cross in the house, and here are the addresses. Now we'll get here. Now we'll import here the rest of the nodes. So let's switch back to the structure. Okay, here's our structure. Now we will import these 2 points. We will put it here so we can easily connect it with here. Now we put it here. Now we see we put it vertical, a little bit lower vertical. Okay, let's create it, and let's create a second one. So they will be connected like this. Sorry, push something wrong. Connected like. What does that mean? I'm pushing something incorrect. Okay, now they are connected. And now these are address 7 and address 8. These one, and now we will connect the last 2 ones. Address 6 and address 5. Okay, we have copied them, and now we will put them after this one. So for instance, we press import, and the first one, for instance, we can put it a little bit higher, and the last one we will put a little bit lower, right here. Now we connect them. Okay, now we connect that one. Okay, done. Does it look okay? Yes, it look okay. So let's say that we need to get, for instance, television or phone or whatever to by one fiber to all of the houses. So for instance, let it be let's use the fiber number 3. So we say it's used for television. We'll put a television socket here. He will say that well, we can put something so this address will be translated through all our network. Let's say it's called something. Now we must connect all our nodes. We connect them. We connect our structure. Yes, the structure being connected this way, and here is everything is connected. Now Let's translate all this stuff to the from address 1 to address 2. I press this button. So here the forward fiber is used. And here we will divide the signal to state here. So we will have a splitter and a socket in each house, in each box. Besides that, you can do fiber connecting just as you like. For instance, you can do whatever you like with the fibers here very easily, like this. That's very easy, and also you can adjust the angle and whatever. So you can get very beautiful fiber crossing. So back to business. We have to on the address 2. On the address 2, we have just to put one splitter and send the signal further. So we must put a splitter with two outputs. We must select some three squares, so the splitter will have three sockets, one input and two outputs. Well, just don't ask me how it works. It works like this. For instance, if you need to connect it, you can check three boxes on other sides, and this will serve for the input, and this will be connected to the outputs just automatically, just like that. So you can see it goes to the input and the outputs go here, but we don't need it. We will delete it. We will delete these fibers and we will deal with this manually. So we take our third fiber, put it here. So this output will stay here. We'll put a socket. It will serve, next we'll the third fiber is taken. No matter what, we'll connect it to the first fiber. Okay, now it is connected. It is connected somehow. So now we get our stuff here. We push it to the next node, to address 3. Push it. Get it in the first fiber. So now on the address 3, what do we have on address 3? We have to get a socket here and send the signals to 3 other addresses. So we must put 3 splitters here. Let's do it. So let's, for instance, do it like this. Create the first splitter and delete the... Sorry, where are we? What happened? That's okay. We delete everything. We get another splitter. We delete everything. And we get a last splitter. Now we delete all the... So now we connect the first fiber with the input. First output will go further on to address 4. Make a connection. The output will go to the input of the second splitter. Where shall it go? It must go to this particular cable. Is it right? Yes, it is. Now we connect it with this one. We'll connect it with the last cable. And so we have divided the signal between these addresses. And we have sent parts of the signal here and here. And also, so now we push the signal everywhere. So it's being pushed everywhere, and here we put the socket, a socket for television. Now we push the signal to the so here this is the end of the address 7. Put a socket, and at the address 8 we must push the signal. At address 8 we get it here and get a socket, and also we must push it here. And now we have just to divide it between, no, not just between these addresses 6 and 5, but also we'll get rid of this cable. Okay, no matter. We must put 2 splitters here. The first one. And the second one. We delete everything. Now this connection, I don't like this connection. Let it be like that. This will go here. This will go to a splitter. This will go, for instance, well, any number of a fiber you like. Here we get the socket. So we got the signals here. We push it to the other sides. And here we just, where is it? It's in the 4th fiber. We put a socket. And we put a socket here. So our structure is complete. Now, what we can do? We can select this fiber, and we can send the optical signal through all the structure. Now you can see that our splitters, they don't have values. We will calculate the values. Now we send the signals outside. Please be patient. Let's wait a little bit. So we've got the structure. I'm sure you are familiar with that. So all the numbers are typical. If we calculate it with the uncalculated splitters, we will get absolutely enormous numbers of a power meter. But we select our power source. We push calculate the splitters. We have recalculated the splitters. Now we can send the signal once again. So now we get absolutely perfect numbers. You can see how small the delta is. So now these are recalculated splitters. Now we can select everything and press this button. It sends the calculated numbers back to our fiber crossing. So to check it, you can, for instance, remember these values on address 2 and address 3. So this is 8515, 50 by 50, 7030, 50 by 50. I select everything. I push send it back to the fiber crossing. Now we are back here. So on address 2 we've got 85 by 15. And here we've got 50, 50, 70 by 30. And all the way to the end of our scheme. This is how it works. I think you must be tired already, so I'll make a pause now. Okay?